When you see a self-driving car navigate a busy street, or when a chatbot just gets what you're asking, it's easy to forget that it all starts with one thing, a model. And a model isn't just a bunch of code. Think of it more like a digital blueprint of our world, a simplified but really powerful map that a machine can actually read and learn from.
And right now, we've hit this incredible tipping point. Seriously, we're way past just teaching AI to recognize cats in photos. We're building these autonomous systems that can actually code software, negotiate deals, or even help discover new scientific materials. It's not about just answering questions anymore, it's about taking action in the real world.
So how in the world are these things built? Well, the best way to wrap your head around it is to think like an architect. We've graduated from building simple structures, like chatbots, to architecting these incredibly complex, goal-driven digital minds. This really shows the fundamental shift. The old AI was basically reactive. You gave it a prompt and it gave you an answer. Simple. But this new generation, it's proactive. You give it a high-level goal and it figures out all the little steps to get there all on its own. I mean, that's a total game changer.
Okay, so if we're architects building these digital minds, what's actually under the hood? What are the core components that give them this amazing new autonomy? Let's take a look at the blueprint.
The official term for this new paradigm is agentic AI, and the key idea is right there in the definition. It's not about answering prompts, it's about achieving goals. These systems can come up with their own sub-goals, pick the right tools for the job, and take a whole series of actions to get it done.
So the magic really comes down to 4 key functions. First up, perception. The agent has to see the world, taking in information through text, sensors, you name it. Second, it needs memory, right? It stores what it learns to connect the past with the present. Third, and this is huge, is planning. It breaks a big, messy goal down into small, actionable steps. And finally, execution. It actually goes out and does those steps using real-world tools.
So we have these agents that can perceive, remember, plan, and act. But how do you teach them? This is where things get really, really cool. We are now training these AI agents inside their own simulated worlds. And yeah, that's a concept that sounds like it's straight out of science fiction.
I mean, just listen to this question from the researchers who wrote the foundational paper on this. Can agents learn inside of their own dreams? The whole idea is simple, but it is so profound. What if an AI could practice and learn, not in our slow, expensive reality, but in its own fast-forward, simulated version of it?
And that's exactly what a world model is. It's a simulated environment built from data. The easiest way to think about it is like a super realistic video game where the AI is the player. A great example of this is OpenAI's video model, Sora. It's not just making videos, it's learning to simulate the physical world, which means it can understand things like gravity and cause and effect without anyone having to explicitly code that in.
This comparison just nails the difference. The old way of training was like studying flashcards. You're just memorizing a fixed set of data. This new way, it's like practicing in a flight simulator. The AI gets to explore millions of what-if scenarios, it can fail safely, and it learns from all these dynamic experiences at a mind-boggling speed. Okay, but all of this power brings us to a really critical point. The choices made by the human architects, the people designing these systems, are suddenly more important than ever before. It's not just about building the most powerful model anymore, it's about building the right one.
Which leads to a question that kind of challenges this assumption that's been floating around the AI world for years. Is bigger always better? Do we really need the largest, most complicated model to solve every single problem? And you know what? The answer is increasingly a clear no. There's a really strong case for what you could call right-sized AI. Smaller, specialized models are often way faster, they're cheaper to run, and they can be more private since they can run locally on your device. It's about avoiding that computational overkill. Not using a sledgehammer when all you really need is a scalpel. The smartest choice isn't always the biggest one.
And this isn't just a theory. In fact, some recent research pointed out a problem called tool space interference. It turns out that if you give an AI agent too many tools to choose from, it can actually create a kind of statistical noise and make it worse at reasoning. It's real proof that sometimes a leaner, more focused design is actually a smarter one.
This is why the architect's job is so incredibly important. Because as these models get woven into the fabric of our world, shaping decisions in our legal system, in medicine, in who gets a job, the mathematical choices made when they were built, well, they stop being just technical decisions. They become, for all intents and purposes, a social contract.
When you just step back and look at the whole picture, AI modeling is this amazing creative act. It's a combination of art and science, where we're teaching a machine not just to see the world the way we do, but to find patterns and possibilities that can help us all see it just a little bit better.
So I'll just leave you with this to think about. If you had the power to be the architect for a perfect model of anything at all, the global economy, how our climate works, maybe even cellular biology, what would you choose to build? The blueprint is yours.